So let's write out a simple for loop. It will look like this. So for item in object, again, object is a container like object, and then item is each item in it. And then we specify what we want to do underneath it, indent it. So for now, let's just print item. Now obviously object is not defined, so let's make it into a list and run it. And right away we are iterating through each of the integers in this list, 1, 2, 3, 4, 5. And if I were to make this a tuple, this will also work. And last but not least, let's try a range. Let's do range. Let's start at 0. Let's end at 20. And let's end at 22 and let's do a step of 3. So now we get all these numbers. Okay? Now, whereas a for loop loops through an object and iterable, a while loop loops as long as a condition is met. The simplest example of this is a counter, where let's say we start at counter of 0, and then we want to step the counter up until 1000. So we can say while, and then we specify our condition, c is less than or equal to 1000, and then actually, let's make it 100 because I don't want to print too many numbers. So 100, then let's increment our counter, then print C. Now, if we run this, we see we generate all the numbers up to 101. Actually, it's going up to 101, which is one more than we want. So we can change that. We can fix that by just making this. And now, indeed, it goes up to 100, okay? So basically, a while loop runs depending on what this condition is, whether it's true or false. In light of this, we can see that if our while loop is poorly designed, we can actually run into infinite loops. So for example, let's say we were to just write while true, and there was no mechanism of changing this. Then we can just say infinite loop. So if I run this, obviously this will just keep on running and running. So I will have to stop it myself, and that's why I get keyboard interrupt. So how you design a while loop is important. You don't want to run it into situations where you get an infinite iteration. Now, one way to break out of an infinite loop is to use the break statement. To demonstrate this, let's recreate our counter. So initialize c to 0, and then while, instead of writing the condition, let's just write true, increment our counter, print it, and now we want to specify our break statement. So if c gets to the point where it is greater than or equal to 100, we want to break out of our loop. So now if we run this, we see that it successfully goes up to 100. Cool? Now the important thing about the break is it only applies to the innermost or lowermost loop. So for example, let's say this counter was nested inside another counter. So I'm going to write C2 initialize to 0 while true. Then I'm going to indent this one because it is nested. I will decrement the second counter and then print C2. Now for each iteration of this counter will go on to 100 and stop, but overall this counter will keep on going because, like I said, the break only applies to this loop. It doesn't apply to the overall loop, okay? So I can demonstrate this and run this, and as you see, it keeps going on forever. Now this is a little difficult to see because I'm kind of printing both of them at once. So one way I can fix this is I can print the inner counters into a list. I can say inner counter into an empty list, and then now I can say inner counter, instead of printing it over here, dot append C, and now I will print inner counter. So now if I run this, it's a little bit more clear to see. So each iteration of, you see the negative number increasing and increasing, each iteration of the outer counter, we are running the inner counter. So now, if I were to take this break statement and put it up here, but now applying to C2, and since it's a negative number decrementing, we want to stop it until it is less than a certain negative number, so less than negative 200, and then we break out of this outermost loop. Now if we run this, we see that we stop at negative 200, okay? Now in this example, we nested while loops. Let's try nesting for loops. So let's try generating 3D coordinates bounded by a solid cube such that the side length of the cube is 10. All the points are spaced a distance of 2 apart, and the cube is centered at the origin. So for example, let me take this out. We can say mesh cube chords into an empty list, and then I'll start with each axis, so for I in range, and remember the side length is 10 but it's centered at the origin, so we can start at -5, then we can go up to 6, because remember we specify one greater than what we actually want, and then our step size is 2 for the space distance of 2. We do the same for each axis, so I'm going to copy and paste, indent this, and then paste one more time. But this time I'm going to call this J and then K, and I can go ahead and say mesh cube chords dot append into a tuple I JK. So now I have generated all these coordinates bounded by the solid cube. So if I were to print mesh cube chords, this is what I would get, okay? All those coordinates. Now, just an FYI, when you're working with a sequence of numbers and you're iterating through them in a nested fashion, especially if that sequence can get large, it's actually bad practice to use nested for loops. It can get very inefficient. It's better to use like vector operations. For example, Python has NumPy library, but I just used the nested for loops here just to demonstrate how you can nest for loops. Now, a common use case when you're iterating through items of a container is you also want to iterate through the indices simultaneously. Well, this is where the enumerate function comes in. This is how it looks like. So let's say we had a list of the first 5 alphabets, A to E, so L, A, now we write for I for the index, comma, then item for the item, and enumerate the list. So now I can print the results in an F string. So F item at index I. So now if I run this, I have successfully enumerated my list. And I could have done similar enumerations for a tuple, a set, and a frozen set. So if I run this, I get similar enumerations. This is for the tuple, this is for the set, and this is for the frozen set. Well, what about a dictionary? Well, in most cases for dictionary, you don't really need to enumerate because it doesn't really make sense to get an index of a dictionary when you have the keys of the dictionary. So the more common way of quote-unquote enumerating a dictionary is to actually use the items method of the dictionary. So we can say for key, comma, val, in, let's say our dictionary is, now we write dot items, and now we can write print f key, the key, and then the value. And now if we run this, we have enumerated through the keys and values simultaneously. by using dot items. But now let's say for some reason you wanted to get the indices anyways, well, then you can still enumerate on top of this. We could say I, comma, but now we have to packet this together because with the enumerations, it's important that the index is separate than the item. Now the key val is what becomes the item. So now I do enumerate. Okay, and now I will write index and then I. Okay, and now it will look like this. We have enumerated on top of getting the key value pairs. Now, if we want to enumerate with just the keys and not the values, then instead of items, we can do keys. Then we can take this out. Now it doesn't have to be packaged into a tuple because it's just a single item. And I will take the value out. Now if I run this, it is just the index and the key. But let's say I want to do by value instead of by key. So now I can say values. Then I'll do val and make this into a val. So basically, these are different ways how you can enumerate a dictionary. You can do it by index, by key, by value, or any combination of. Cool? Now, if you thought the enumerate function was handy, well, there's more. There's the zip function, where if you want to enumerate through multiple sequences simultaneously, this is where you can use it. So let's say we had list, tuple, set, and dictionary. All of them have 6 items. This is how we could iterate through them. So for li for list item, ti for tuple item, si for the set item, and di for the dictionary item. In zip l, t, s, and then the values of the dictionary. And I can write print f string for the list item, the tuple item, the set item, and the value. Now if I run this, I have iterated through each of the containers simultaneously using the zip function. Cool? Now, if you're more careful with syntax and how you package your items, you can even be more thorough with the zip. For example, you could even write something like this. Now, this may seem like a monster, but the important thing is to follow through with your item. At the very beginning, we have enumerate. So we have the index I matching with enumerate. Then we packet our overall item next to the enumerate. So that is the zip. So now we are inside the zip. We have list, tuple, set, and last but not least, we did dot item. So now we packet that internally into a key value pair. So now we can run this, and this is what we get. And last but not least, we can even iterate through multiple sequences that have different lengths. For example, we can do this, but the loop will stop once it reaches the final value of the smallest container. So think of the smallest container as like a bottleneck in this situation. So if we run this, we can see we only printed 4 items because the bottleneck was the tuple of 4, even though these ones had more.